All right, ladies and gentlemen, we are looking at the proofs of quadrilaterals packet. We're looking at number 1. We're trying to prove something is true for a general parallelogram, so we can say it's true for all parallelograms. Okay, first we had a drawing already done for us, and we picked the points. We decided M was at 0, 0, E was at B, 0, I was at A, C, and then T was B plus A, comma C. So then we found the slopes for all of them. We get the slope from I to M is C over A. The slope for E to T is C over A. So we know those are parallel. And the slopes for M, E, and IT were both 0. Okay? So even though we used zeros and then letters, we found all the slopes. We found that 2 of them are parallel to the other 2. Nothing is perpendicular. Okay? So that means it could be a parallelogram or it could be a rhombus at this point if we have 2 sets of parallel sides but nothing's perpendicular. Okay, so we defined the term segment bisector. A segment bisector cuts a segment in half. You might not have the exact wording I do, but close. Okay, same meaning. A segment is a bisector if and only if it cuts a segment in half, because we know the converse is true and it is true. And then we had to prove that the diagonals of a parallelogram bisect each other. So we used the midpoint formula and found that M to T was B plus A over 2, comma C over 2. And I to E was also the same thing because B plus A is the same as A plus B over 2, comma C over 2. Questions so far? Okay. Let's go ahead and move to the back. BJ, you got your packet? Yeah, let me come look at it real quick. I'm going to put 2 up here. Remember, your letters might be different than mine. But it's the same thing. The hardest part was sketching that square and labeling the points, I believe. Using your origin as one set of points is really helpful. So we've got, I'm labeling it H is 0, 0, G is A, 0. Well, E would have to be 0A because it has to go up the same amount it went over. And so F is AA. And then I'm going to find all of their lengths and all of the slopes. Because I know if all of their lengths are the same, it could be a square or a rhombus. And if I find that their slopes are parallel and, excuse me, thank you, and perpendicular, I know it's a square. So I found that EF was A. I did EF squared equals A squared plus 0 squared. So I got EF squared equals A squared. So they took the square root of both sides and got EF equals A. It's pretty much the same thing I did for FG is A, GH is A, and EH is A. If you used a different letter and got like they're all B or C, same thing. Okay. Then I found their slopes. The slope of E to F was 0. The slope to FG was undefined. 0 and undefined means they're opposite reciprocals or perpendicular to each other, right? Because 0 is on the top for one, 0 is on the bottom for the other. Opposite reciprocals. GH is 0 and EH is undefined. So we've got 2 sets of parallel sides, and we've got perpendicular consecutive sides, and they're all the same length, so we know it's a square. So we're going to, am I going too fast? You guys should just be checking your answers, so it shouldn't be too bad. All right, C, if a segment is congruent, then the segment is equal in length. A segment is congruent if and only if the segments are equal in length. Then we had to prove that the diagonals of a square are congruent, so we use the distance formula because it's congruency, right? Because they have to be the same, so they have to have the same length. We found that FH was the square root of 2a squared, and EO was the square root of 2a squared. So we should be good there. Any questions so far about number 2? We ready to move on? Okay, let's look at the back. We got, if the lines intersect at 90 degrees, then they are perpendicular. Excuse me, if the lines are perpendicular, then they intersect at 90 degrees.
Excuse me,
yes.
Can you go back to B?
Not right now, honey, but Miss Warren's got it for you, so she's going to give it to you later if you need it. Okay? Lines are perpendicular if and only if they cross at 90 degrees. So we had to prove that the squares' diagonals were perpendicular. So we used slope to figure out perpendicular, right? We talked about this every morning for the warm-ups, what we use. So h to f is 1, and e to g is -1. So they are opposite reciprocals, right? 1 over 1, the opposite of that is 1 over -1. All right, let's look at 3, and then we're done, guys. And then you can work on your review. So we're looking at 3. I knew it was a rectangle, so I've got E at 0, 0, D at A, 0. H I've got at 0B, because it can't go over the same much it goes up. And then I've got I at A, comma B. So I found the lengths of all 4 sides and the slopes. I found the length of HI was A, the length of IG was B, the length of DE was A, and the length of EH was B. I found that the slopes of HI were 0, the slopes of ID was undefined, the slopes of DE were 0, and the slope of EH was undefined. So opposite sides are congruent, opposite sides are parallel, and consecutive sides are perpendicular. Okay. Any questions about B for number 3? C, we've got H, we've got to prove that the rectangles diagonals are congruent. So I went H to D, and I got the square root of A squared plus B squared, which looks really funny, but the point isn't what the answer is. The point is that it's the same as E to I, which it was. They're both the square root of A squared plus B squared, so we've got congruent diagonals.
Can you light it up? I can't see you.
Okay, I can't make it any, I could try. That's as light as I get. All right, and let's do D together. I had a lot of people not do D, so I left it blank so we could do it together. Okay, we're going to prove that the diagonals are perpendicular. What formula are we going to use for perpendicular? Slopes. So I know I'm going to use the slope formula, and that's going to be y2 minus y1 over x2 minus x1, and I want the 2 diagonal slopes to be what to each other? The same, totally different, what? Opposite reciprocals, that funky word, which means if it's 1/2, I want the other one to be -2 over 1. Okay, so let's look. We've got H, D. So H to D, we have, I know points H is 0, B, and I know point D is at A, 0. So I'm going to take the y's, so I'm going to go 0 minus B over the x's, A minus 0. So I'm going to get -B over A for HD. Now I want E, I, and I know E is 0, 0, and I is A, comma B. So I'm going to go B minus 0 over A minus 0, right? I did the y's, and so I get B over A. Now I'm trying to prove that they do not have to be perpendicular. So are these perpendicular? Are they opposite reciprocals? They're opposite. One's negative and one's positive, but did I flip the fraction? No. Do not have to be perpendicular. And that's it. If you did 4 and 5, that was extra credit, so I'm not going to go over those. Okay. And you can now work on your review packet. I've got mirrors, patty paper, compasses here. You've got this packet to look at for part of your review packet. You've got your properties of quadrilaterals to look at. Okay?
That packet, I thought we had to do 3 of them.
No, Matthew.